For radius of curvature, you need to remember the formula. This formula we'll use when the question is in terms of x, f of x. So dy by dx whole square, d square y by dx square. When the question is in terms of y, that time this formula, radius of curvature equals to 1 plus x1 square by x2 whole power 3 by 2. This one for polar form, if anything is given in terms of cos theta, sin theta, that time we'll use radius of curvature equals to r square. So this is polar form. Then dx by dt, dy by dt, if the questions have two functions x and y, that time we'll consider this formula. This is parametric form. Parametric function is given to us, two equations are given in parametric form, that time radius of curvature we'll use this formula. Then after parametric form, if fx square plus fy square, this formula is given. This is given for implicit function f of x comma y. If the question has x square y cube plus x y square, in that form if any function is given, that time radius we'll use, radius formula we'll use for this one, rho equals to fx square plus fy square whole power 3 by 2, so on. Then one basic formula is also there, rho is equals to ds by d psi. To find this one, suppose s square equals to x square plus y square. From curvature, if an arc is given to us, in that arc this condition is satisfied for every arc, s square equals to x square plus y square. If we'll apply derivative all those three terms, and if I'll apply divide this one by dx square, so this becomes ds by dx whole square 1 plus dy by dx whole square. Once we have whole square, we know that dy by dx is slope. When the curve is given to us, this angle is given, suppose this angle is psi, so dy by dx is tan theta. So if the angle is, I'm not considering theta for angle, we are taking tan psi whole square. 1 plus tan square is secant square. Now if we have secant square psi, both are having squares, so squares cancelled, ds by dx equals to secant psi. If I'll inverse this one, what I'll get, dx by ds equals to cos psi. Similarly, if we'll consider s square equals to x square plus y square, I'll divide this one by, first we'll apply derivative to all those functions, and if I divide this one by dy square, so ds by dy whole square plus dx equals to dx by dy whole square plus 1. dy by dx is tan, so dx by dy is cot in terms of angle. 1 plus cot square is cosecant square. Squares cancel from both sides, ds by dy equals to cosecant psi. So dy by ds is equals to sin psi. So apart from those values of formulas of radius, you need to remember these two functions, dy by dx, ds, dx by ds, to find radius of curvature in other form. So direct formula for radius of curvature is d by d psi of s. In that, if we will consider this condition s square equal to x square plus y square, this condition is whenever any arc is given to us a to b, in that this equation satisfies for that arc. So s square equals to x square plus y square, If you apply derivative, divide by x square one function you will get, divide by dy square you will get another function. So when rho, we are remembering this rho formula, you can also remember dy by ds is equals to sin psi and dx by ds is equals to cos psi. Okay, now we'll discuss some problems based on those formulas of radius. Find radius at a point on the curve. S is given to us, C log secant psi. Now we have to simplify with respect to psi. See, variable x is not given to us. So this whatever angle is given, we have to differentiate with respect to that angle. And we need to find ds by d psi of s. So differentiating both sides, first we will consider s is equals to c log secant psi. Now differentiating both sides with respect to psi. So d by d psi of s equals to c into d by d psi of log secant psi. Now derivative of log is 1 by into d by d psi of secant psi. Now 1 by secant psi, derivative of secant x is secant x tan x into d by d psi of psi. So this is anyhow 1. C into tan psi into 1. So ds by d psi. Therefore ds by d psi represents radius c tan psi. Once again check it out. S equals to, when function is given to in terms of s, immediately you should differentiate whatever angle is given. Suppose this is theta, that time you have to differentiate both with respect to theta on both sides. Then ds by d psi you will find. To simplify this function, basic formulas, when you find dy by ds or dx by ds, that time you can remember these two formulas, dy by ds and by ds. So we can consider right hand side now. In right hand side we find d by dx of dy by ds. Now we know that dy by ds is how much? Sin psi. Now if I differentiate with respect to x, sine function cos you will get into inner function is psi. So d by dx of psi. Cos psi is given, d psi by dx when cos psi is given to us, d psi by dx is given, we find that dx by ds is given to us. There is no psi given. So we can multiply and divide by s here. ds we will consider here, ds by dx. You can write this one, this function ds by dx, by splitting this one by taking ds here into ds. ds cancel, you will get ds by dx itself. Once you get this function, we have two values, ds by dx is there. It is given in reverse form. So we can consider this value, as we know that dx by ds is equals to cos psi. So ds by dx is equals to 1 by cos psi. So we have cos psi already. d psi by ds is there into this value is 1 by cos psi. So cos psi cancelled. d psi by ds we got. Now d psi by ds we have the formula, radius is ds by d psi. What we got? d psi by ds. That means we got inverse of, reciprocal of that radius. So 1 by rho equals to LHS. Check once again. We have started by taking RHS, d by dx of dy by ds. dy by ds value, what you have to remember? dy by ds is sin psi. Sin psi we have to write. Then differentiate this one by taking inner function also. After differentiating, we find d psi by dx. But to find radius formula is ds by d psi. There is s present in this one. To get that s value, multiply both ds, multiply and divide by ds, so that d psi by ds into ds by dx is there. So ds by dx value is 1 by cos psi. How we will get that one? dx by ds is cos psi. So reverse this one. After reversing this becomes reciprocal of it. Substitute, cancel, whatever remains that represent 1 by r. We know that dy by ds is equals to dx by ds is equals to dx by ds cos psi, and dy by ds is equals to sin psi. How we have to recall those values? By saying this one, leaving that higher second order derivative, dx by ds is there, by leaving the 2, and here we have dy by ds. By seeing these two terms, we have to consider these two, as we know that these two values are cos psi and sin psi. Once we get these two values, now I am differentiating again with respect to x. With respect to s is there. So differentiating with respect to x on both sides. With respect to s. Here also differentiating both sides with respect to s. So d by ds of dx by ds is equals to d by ds of cos psi. Same thing, d by ds of dy by ds is equals to d by ds of sin psi. This is d square x by ds square, as what we needed here. Derivative of cos is minus sin into inner function d psi by ds. Here same thing, d square y by ds square equals to Sine is cos. Derivative of sine is cos. Then d psi by ds. Minus sine phi. Sine psi. Rho is how much? ds by d psi. What we got? d psi by ds. So we can write 1 by r. This is d square x by ds square. And here we can write cos psi into 1 by r. Now we will consider RHS. RHS as this first term, this term whole square, 1 by rho square, plus second term, this one. This is equation 1, equation 2. Second equation whole square is cos psi square into 1 by rho square. Sin square plus 1 by rho square common. Sin square psi plus cos square psi. So this is 1 by rho square into 1 equals to LHS. So from here we have not considered RHS. In spite that, what we have done, we have to consider ds by ds, dy by ds, two values, differentiate both sides with respect to x. So you will get d square x by ds square. Here also you will get d square y by ds square. Then inner functions are there. Then once we get the answers, d psi by ds, by seeing this d psi by ds, you have to remember that ds by d psi is rho. So d psi by ds is 1 by rho. So both formulas we have to replace it by 1 by rho for both equations. Then RHS you have to consider first one square, both will get square. Second one square, both will get squared. Once we get both squared, you can get the value of LHS. So in this way you will be having some row problems. You can simplify. Few questions are given to you in class. That time you can simplify and you can write them.